Ich begrüße Sie hier.
I would like to welcome you most warmly. I'm really happy that I can be with you, that I've been invited to speak to you. Before I start with my presentation, I would like to take up 2 points that we have heard about today already. First, the fact that developments in aviation and avionics take a long time. I can only confirm that to you. When I started to work with MTU end of the 80s, there were already projects on the geared turbofan, prop fan, etc. At that time, a concept was followed that was called advanced ducted prop. Maybe the one or other knows that concept. I saw Mr. Holster today. At that time, I carried out tests with him at the DLR Göttingen. Wind channel models were tested of the CRISP, the MTU concept, and a turbo fan. And that was end of the 80s. So it took nearly 25 years till this concept became successful for engine design. The geared turbofan is nothing else than the advanced ducted prop of Turton Whitney at that time. In the meantime, the concept disappeared because fuel prices went down or didn't grow or didn't increase as expected. At the same time, if you take a look at that today, we're at $3 per gallon fuel, and that was the driver of this development. We have 5 platforms for this geared turbofan concept, and I would like to present them to you today. And in the year 2008, we had a fuel price at about $4 per gallon. That was the year, July 2008, where the CCS of Bombardier was launched. And this is one platform that I would like to talk about today. That was the one point. And the other point is open rotor that I would like to talk about again. Open rotor has been in discussion for a long time. Open rotor optimizes fuel consumption. And at the moment, with respect to noise, they are not just as the geared turbofan. I will show you pictures in a minute, but also with noise, the open rotor will be improved, I'm sure. But what we'll see here today are features that will be launched next year. The decision has been taken, it will be built, and we'll see the improvements. And hopefully not only airlines will be happy about savings promised to them, but also populations that live close to airports, etc., will be relieved. With more air traffic movement, a growth of 5 to 6% per year, we really have to do something very quickly. It's about the timing. And I will show you on the slides. Would like to talk about the concept of the geared turbofan, the applications that we have developed already. I will talk about the development status and then offer you an outlook. Have a look at this difference of a conventional turbofan and a GTF. First of all, the difference is that with a geared turbofan, there is an additional component in the engine, which is the gear, as the name tells you, geared turbofan. It's a component that the fan and that separates the fan from the low pressure turbine. So you can set both separately. Before, with a turbofan, you were limited in the way, like the fan tip speed wasn't to be too high for noise reasons. So you want to have a slow-running fan to be effective, but you would like to have fast components with the turbo machines. So the best thing is to decouple it, and you can do that with a gear. Wittmann decided to carry it out, and MTU is a partner in this program. The advantage is that on the one hand, you have very clear improvements with component efficiencies. That is, the gear saves, the engine saves fuel, emits less CO2. The noise is reduced, but also maintenance costs are reduced. Have a look at the geared turbofan. The most important component is the gear system, the drive gear system, which was developed new. It was regarded risky for a long time to have a gear system installed. There were a lot of tests carried out at Pratt & Whitney and MTU, and then this concept was implemented. You need more components to build this geared turbofan. You need a high bypass, low-speed fan with a very low bypass ratio. The more the saving and the less the noise. We need a fast, low-pressure compressor, so it's 3 times faster than the fan, this compressor. All components on the low-pressure compressor have to develop newly. MTU is responsible for the speedy low-pressure turbine. With different technology projects, it was developed in the last years. And then we need a very performing core gear system. Of the 8 levels of the compressor, turbofan is responsible for the first 4 first levels. That's the part that MTU builds. Depending on the application, MTU has 15 to 18% of the total gearbox system or gear system. Have a look at this picture. Look at the curve. Here, the red curve is fuel consumption, fuel burn, as a function of the bypass ratio. With the straight line, you can see that it turns upwards at some stage. So if you have a higher bypass, you need more low-pressure turbine levels. You have more weight. You have in a cell that is too big, that is fuel consumption will go up at some stage. You reach an optimum with a certain fan diameter at some stage. With the geared turbofan, the curve looks similar, but it's shifted downwards. So you have a higher bypass ratio and you can achieve more savings. What's nice about that story is that if you take a look at the blue curve, that's the learning curve, at the same time you can have a side effect, and that is noise becomes much lower than with a comparable advanced turbofan. Okay, you can improve an advanced turbofan with a lot of efforts. We have seen what is possible, but here you can get it very easily, as you have the much lower fan tip speed and the higher bypass ratio, as the fan pressure ratio is lower. Look at the potential of the geared turbofan. We assume that 15% saving will be possible, fuel consumption and CO2 emissions, and 15 to 20 dB compared to level 4, cumulative. It depends on the application, the power setting, and the thrust of the engine. But you also see in this picture that this is not the end of our development. Geared turbofan, just as any turbofan today, can improve its own components. That is, the total pressure situation is improved. Temperatures can be increased in the turbine. So here, further savings might be possible. With the possibilities that we see with higher bypass ratios, we are at 12.5 at the moment with the Neo, and we can do it in generation 2 further upwards. And then we would reach more savings, more reductions in noise compared to the standard today. Here are the famous pictures. You like to see them, I assume. These are the noise footprints. We heard about that several times today. 3 examples. That's Frankfurt's runway west. The blue is the 75 dB curve. So with a comparable aircraft with a geared turbofan power, it can be reduced by 15%, the affected area on the ground. Similar example is Munich Airport. Mr. Fail knows it. I think he presented it in Munich already. It's a similar situation, clearly reduced noise footprint. And the third picture is Zurich, where it looks very similar, about 3/4 smaller, this area affected on the ground, compared to conventional vehicle. That is a 787-800. Similar picture again, the Geared Turbofan, and maybe airlines are interested. It's always an incentive if there is fuel reduction and maintenance cost reduction, then they would buy the Geared Turbofan. We have more than 50% market share in the NEO. Lufthansa is represented here by Mr. Buchholz. They decided in favor of the GTF with the CCRSR and the NEO. And I think that shows that this is really a well-developed design. Not only fuel consumption is optimized, not only noise is optimized, not only maintenance is optimized. There are examples that prove that. The 6000 was a development in this direction, but this is a really balanced design where there are advantages all around. Maintenance cost improvement due to the fact that you have fewer stages. You have fast-running, lower-pressure turbines, much more efficient per stage than with a conventional system. You have fewer parts. You have relatively moderate temperatures at the moment and lower maintenance costs as a result. If we summarize this, we assume that a fuel consumption reduction of 15% is possible, which means with a NEO compared to an A20 per year, a saving of $3 per gallon. That is about $1 million per plane per year. Then we have 3,600 tons CO2 reduction, which is about, according to 1,000 mid-size vehicles a year. Noise, Cape 6 minus 50% with the NOx emissions. So Cape 6 here will fall short of 50%, and Cape 8 will come very soon, so we're much doing better. Noise up to 15 to 20 dB accumulative compared to stage 4. Probably we reach that. We do flight tests already with Bombardier. We don't know the results as yet, but it has been confirmed already that it goes in the right direction. With maintenance costs, I mentioned them before, lower than with similar thrust at the moment and similar application profile, and we will launch first. We will launch this engine first. The competitor's engine will come 9 to 12 months later. Now have a look at the applications for the Geared Turbofan. There are 5 applications. The first is the Bombardier C-Series, the 100, the smaller variant, that will be launched 2014. Lufthansa will also launch the first machines 2014. The second application mentioned here is not topical. I wanted to show you a later version, Mitsubishi, postponed from 2015 to 2017. Well, we are not affected that much in our region. There are 3 customers that are not in Europe at the moment. Airbus A320neo, October 2015. That's still the target. I come back to that later, what the state of the development is here. And in January, we have the MS-21 of Air Köppel. It's as similar as the A320 family, a bit larger, 160 to 220 seats. For that, the PB1400G is one of the 2 options here for the gear system. For Bombardier, Mitsubishi, and Embraer, the Geared Turbofan is the only solution. For the MS-21 and the A320neo, there are 2 engine suppliers. Embraer in January 2013 decided to do the re-engineering of the E-Jets, a successful aircraft family. more than 1,000 of them have been sold. They want to use the Geared Turbofan. They won't have 4 times the M370, 75, and 190, but they only will have the 175, the 190, and 195. And they will start with the M319 in 2018. It will start service. The same gear systems with respect to the turbo as Mitsubishi and Bombardier use. Bit different thrust, a bit different installation, but similar turbo systems. Now, briefly about the planes. The Bombardier C-Series is a 5-abreast cabin that is between regional aircrafts and single aisle. The A20, 787, 110 to 135 seats, all economy. Range 3,150 Nordic miles. Launched 2008 with a fuel price of $4 per gallon. Enter into service 2014. At the moment, 177 firm orders, 211 options, about 400 aircrafts altogether in the pipeline. Mitsubishi Regional Jet. It's a 4-abreast cabin. 2008, in March, it was launched before the CCLS. And in 2017, it will start service. 165 firm orders and 160 options, so more than 300 aircrafts in the pipeline. The big hit, that's the A320neo, an aircraft which was ordered more than 2,380 times. And there are 1,090 options, so 3,470 in the pipeline. Lufthansa ordered it as well with a Geared Turbofan. So it's 15% fuel saving compared to the A320. It's much quieter. We've seen the figures of Airbus today. So for the A320, 15 dB under level 4 will be reached. In December 2010 it was launched, and in October 2015 it will start servicing. Last application, the MS-21. Don't want to talk about it in detail. Similar as the A320. In 2017 they will start service with it, and one application is the Geared Turbofan. The Embraer E-Jets. 4-abreast cabin, 2018 it will start servicing. Has a bit shorter range, only 4 people next to each other in the cabin, so it's a bit limited with respect to the maximum number of seats. 165 orders have been placed, 200 options, that is a total of 365 aircrafts. So all this together would mean that more than 4,500 Geared Turbofan systems of different models have been ordered. The main point, more than 2,000 definitely for the A320neo, and the others break down to the 4 other applications. Now, what's the state of the development of the Geared Turbofan? The Geared Turbofan in February 2013 of Transport Canada was permitted, was approved of. That is, it has its type certificate. It is mounted in the CCVIS, in the flight test aircrafts. CCVIL carries out flight tests at the moment. 2,500 hours altogether, and in the next 12 to 15 months, they will finalize the tests, and at the end of the test, it will enter into service. So that will be in the middle of the 3rd quarter 2014. First flight was on the 16th of September, a bit delayed, not because of the gear system. The gear system was there in time. There were other issues. But I think the flight test runs sufficiently and successfully at the moment and will really achieve its targets. If you take a look at the developments here, you've seen that most engines go into NEO. So it's important to see how the NEO program does. Well, the NEO program benefits from the two other development programs. The gear systems are very similar. The configuration is nearly identical. That is, the findings of the two development programs, Mitsubishi and Ceres, also go in the development of the NEO. And this takes risk away. That's a big advantage. Start of service end of October 2015. Well, that shouldn't be a problem. The NEO engine flies already. That's a flight test that I show you here. It started on the 28th of November 2012, and since the 15th of May 2013, the flight test program has started. And, well, here several hundred hours in the air have been mastered successfully. How will be the future of the geared turbofan as we see it? There's one application where the geared turbofan was not applied. That's Boeing 737 MAX. Further development of the 737 NG. One big reason for us that the landing gear was smaller. So the fan diameter at the 737 was highly limited. And for that reason, the geared turbofan cannot fully exploit its advantage to 100%. So there would have been a compromise solution, and that would lead to a situation that it would lose compared to competition. Basically, the geared turbofan is not limited to the thrust class that it is being used at the moment, 16,000, the A320, 30,000 thrust, probably with a different transmission. It can be adjusted to any thrust range. There is also mention of a follow-up of the 757 of Boeing, but also larger aircrafts up to wide bodies. Okay, I would like to thank you very much for your attention. Should you have any questions, I'm here.
Presentation and for the contents, and with that I open the discussion for this presentation. So all of you are now ready, hopefully, for raising a question, for giving comments. So please, over there, Frau Barth, also indicate your name and your organization.
Regine Barth, wissenschaftliche Begleitung des FFR und Öko-Institut in Darmstadt. Meine Frage an Sie, wenn Sie sich was wünschen dürften von denjenigen, die...
If you had a wish, framework conditions, European Union or Germany, if you had a wish to have or to make sure that population affected can benefit from your new technology as quickly as possible to a major extent, so that aircrafts are fitted or retrofitted, what would be your wish? If I understand the question in the right way, my wish would be that the market launch happens quickly of the new gear system. Is that something where political framework conditions could help? And if so, how should they look? Well, at the moment, technologies that have been developed are implemented in real gear systems that will be launched next year. Political framework conditions, well, the gear systems cost money. Aircrafts cost money. Probably one should it make easier for customers who buy aircrafts.
With my last slide, the question is, are you asking for political decisions to force you to do different developments, or are you sure that the industry, the airlines are fast enough, or are yourself fast enough to produce, and you are convinced that responsibility for noise is an important driver? So the question is, do you need a political pressure?
I don't think so. Well, im Moment ist es so, dass natürlich
At the moment, people work already with the generation 2 of the Geared Turbofan. The development will go on. The next level of improvement will come. This has been sold, what I introduced to you. They will be produced as quickly as possible. In Munich, MTU built a new hall, production hall, 3,500 compressors, and gears will be built there. So also, with respect to implementation of all these technologies, we are limited in terms of production capacity. We can't produce it faster than at the moment in Munich. It's a big challenge to produce the unit numbers that I mentioned. I think, first of all, we have to work the plan.
Here? Wait, you need a microphone. Otherwise, we will not understand what you're saying.
Walter Phil aus München, nachdem diese Triebwerke, die Sie vorgestellt haben, ja.
I mean, your geared systems are highly interesting for noise reduction and fuel reduction. Are they also appropriate for retrofit programs? Because that would be more favorable for airlines. I've heard such a question before. Well, basically, the gear system is also possible as a retrofit. But with the NEO, for example, modifications in the plane need to be carried out. So reinforcements of the wing, the Geared Turbofan has a higher weight. The weight of the aircraft changes as a result, and therefore you have to modify the aircraft as such. In how far it pays off and in how far this will be considered, I don't really know. I haven't heard of any cases, but basically these are designs that are meant for new aircrafts.
Retrofitting any aircraft?
not for the moment, yes.
Okay. Further questions? Please.
Hi, do you hear me? Yes. Martin Wall, Swedish Airports.
Martin, Sweden.
And when those results will become public?
I didn't get your question. Could you please repeat?
Me neither. So can you repeat it slowly?
Slowly, okay. The noise certification tests for the CS series,
Yeah.
when will they take place and when will they become public?
I do not know the real dates for that, but what I know is that one of the issues is to get the C-Series into the Bishop Airport of Toronto, and I guess there's a lot of pressure on that, so you probably get the answer very soon.
Okay. Further questions? That is not the case right now, so please don't stand up right now. I would like to inform you about two things. Thank you for you, so you can
Thank you very much.
back.